Welcome back, and we're on to the final 2 questions of my 10 questions I ask in my opening lesson. As you may have heard already this week, these questions are not designed to be super challenging. They're not designed to catch you out. They're just designed to show you the absolute minimum set of skills you need to be completely okay with in order to go through the course at the pace we tend to go through. Now, that's not to say that some people don't get these wrong and have to go away and do a bit of practice, but it's just, again, supposed to promote the idea that you need to be on top of your GCSE basics. And that is a clear difference between A-level and GCSE. A-level, there's a lot of assumption as to what you know, whereas GCSE, there are 3, 4, 5 marks for doing a pretty straightforward skill. All right, today is let's not call them extension, let's call them slightly trickier questions in order to make sure you understand your topic. So there's 2 of these. The first one's okay, the second one's a bit more challenging, both of which can be done with GCSE knowledge, if not a bit less than GCSE knowledge. So pause the video, have a go at the first one. Can't make it any clearer, do not use a calculator unless you want to check your answer, of course. Back in a sec. Okay, so this first one comes under the idea of this is why we get you to practice maths. Because as a maths teacher, I see this question and immediately know what I'm supposed to do, because something just triggers inside my head, and this just comes with practice and doing extra questions outside of the lesson. So to me, what do I notice? Well, the first thing I notice is I teach, or I've been taught, that I cannot combine index values where the base value is different. Now I can use logs, but this isn't a logs question. So what else can I do? Well, often these questions involve the numbers 2, 3 and 5. So I can see a 5's there and I can't see a 2, but I do know that 4 is 2 squared. So I can write 5 to the power of 5 times 4 to the power of 7 is the same as 5 to the power of 5 times 2 to the power of 14. And again, 2 squared is 2 to the power of 2, 2 times 7 is 14, where that comes from. Like I say, these should be skills we're absolutely fine with in order to sort of get on with the course pretty simply. Now the trick, and I use the word trick often incorrectly, of course it's not a trick, it's a clever thing you can do to help you get to the right answer when you're not allowed to use a calculator, is I know that 5 times 2 is 10, and 10 is a really easy number to work with. So if I could borrow 5 of these 2's from the 14 and then deal with those other 2's later, that would help me. So I'm going to write this as 5 to the power of 5 times 2 to the power of 5, and then I've got 2 to the 9 left over. Well, if I now think that 5 times 2 is 10, I can put the 5 times 2 inside a bracket and the 5 on the outside, which is going to give me 10 to the power of 5. And you may not know this one straight off, but you should know that 2 to the power of 4 and 2 to the power of 5 and 2 to the power of 6. So you might know 2 to the power of 8 is 256. So therefore 2 to the power of 9 is 512. That is not an unreasonable thing for you to be aware of. Now, that's not really a number as such, so I'm going to put it in standard form because that's a completely acceptable number. So that's going to be 5.12 times 10 to the 7, which of course you could write as an ordinary number. Not too bad, not a terrible question, nice little question to get you thinking and make sure you understand your rules, and more notably, make sure you don't do stupid things like write 20 to the power of 7, which I have seen a few times. If you got that, well done. Question 2. So we do have, this by far is the question to keep people busy if they're really, really quick at maths while everyone else does the questions. So I will always end with these at the end of any questions that I do. They are designed to be very doable, but also get you thinking. How am I going to do this question? Well, let's just look at what I've got. So I've got something plus something equals 220, something plus something 221. So I've got 2 equations, let's label them 1 and 2. Now, because I like the number 1 as opposed to the number 4041, I'm going to do equation 2 minus equation 1. That's going to give me something. I'm not for a second suggesting that's going to answer my question. What I do notice is the first term and the third term both contain an A, and the second term and the fourth term both contain a C. And if I factorise that out, I get this expression here. Now, it did feel a little bit like a quadratic-y type thing that I could do, and in this case, I've kind of got to the stage I can factorise. You get good at spotting these. Some of you may not have spotted that. Then what I've noticed is, well, this is a bit annoying because I've got a plus C and a B minus 1. So if I make that minus C and a 1 minus B, well, then I can factorise out an A minus C, and that's going to give me this expression here. And I can't solve that. That's not possible to solve with the information I have because there's too many solutions. Except for the fact if I read the question again, and again, if you've seen any of my other videos, this is not an uncommon thing within the videos. It says find the integer solutions. Now, if you think about it, which two numbers multiply to make 1? Well, there's only one pair of numbers that to make 1, and that's 1 and 1. So therefore, if I know that A, B, and C are all integers, well, therefore it must be the case that A minus C must be equal to 1 and 1 minus B must be equal to 1, because that's the only way with integers to get 1 times 1 is equal to 1. But it's not though, is it? And of course, that's part of the point of this question, because the other way of getting 1 is to do minus 1 times minus 1. So A minus C is minus 1, 1 minus B is minus 1, and I've got my two ways of solving the question. Let's do the easy one first. So if you look at the higher row, so A minus C is 1 and 1 minus B is 1. Well, if 1 minus something is 1, the something must be 0. So B is equal to 0. And I can carry on working out the rest of the equations. In the second one, it's not terrible either. I've got 1 minus something is minus 1. So therefore the B is 2. And so I've got my values of B. Now in the first case, if B equals 0, if I go back to my equations, well, anything times 0 is 0. So that tells me that C must be 220 in equation 1. And similarly, anything times 0 is 0, which tells me A is 2021. Second set of equations are slightly trickier because I've set up some simultaneous equations, but we can do those even on a non-calculator paper. So multiply the second one by 2. I've got two things, both contain 2A, take them away from each other, and I get 3C equals 2022. Divide by 3. At this stage, I'm hoping for a nice number, and indeed I do get 674. If I know what C is, I know what B is, I can find out what A is, so put that to my equation, I get 673. Now, again, presentation of answers here is important. As long as you're really clear which solutions go with which, you should be okay. So I'm writing it like this. So my solutions in the format A, B, C, so a bit like a coordinate, are going to be 2021, 0, 2020, or, because they obviously not the same set of solutions, 673, 2 and 674. I would say probably about half my class get there, mainly because I don't give them enough time. About half my class get there, maybe a few more. So if you got there as well, well done. Like I say, these are not skills that will get you through further maths. They are a minimum set of skills that you need to make sure you understand, albeit with these last two questions being a bit more extensiony than you really need. As ever, comments down below, do like, subscribe, make sure we get this channel growing slightly larger, and I will see you for the next set of questions. Thanks all.